Right, so today we're going to talk a little bit about something called, it's called quality function deployment. That doesn't mean a whole lot to you, but it's also known as the house of quality. So at this point in the design stage, we have a tremendous amount of information, right? We spent some time finding out our customer needs. And because we did some surveys and did some interviews and such, we have some information on how important they are, how important each need is, which is great. You're currently working on some benchmarking research, right? Where you're looking for what are competitors capable of, what are other solutions to this problem. Related, what do we want to call this? Related solutions, right? Related solutions. And you've developed an extensive list of engineering requirements. Which, remember, these engineering requirements are metrics, right? This is how we know how good our design is. These are metrics for evaluating design. Okay, so really, engineering requirements define to a large extent the problem that we're trying to solve, right? Now, this is a lot of information. So we want to try to organize it because a lot of it conflicts with itself. So for example, if we want to, well, that's not an example. For example, if we want to talk about car seats have to be light, right? They have to be light because we have to be able to easily put them into and out of a car, which is not always easy because you're bending over and the doors are not always very large for the back seat. They have to be very strong, right? And not bulky, if at all possible, and of course cheap, right? And there's ways of making things very strong, very light, and not bulky, but it's difficult to also get the cheap in there, right? So as a result, most car seats are made out of plastic, but in that sense too, there's a trade-off because you want car seats to last long. But most plastics degrade in quality over time. So, in fact, most car seats have expiration dates. I don't know if you knew that. Fascinating. Yes, I just learned that about a week ago. I'm using it. All right. So, what we need is a way of organizing this information in such a way that allows us to prioritize different engineering requirements and prioritize different things so that we're not basing this, remember, not basing our design choices on gut feeling. Oops, feeling, not feeding, feeling. Right. We're not basing our design choices on gut feeling, okay? So even though we might really want to make our car seats very strong, it may turn out that it's far more important to have it not be bulky, okay? And that's the kind of thing we're going to try to discover today. And the tool we're going to use is the house of quality. The house of quality. So the house of quality has several different several different rooms is what they call them. So on the left-hand side here, this room right here, we have our customer needs. So we're going to make a whole list of customer needs. All right. So each row, as we go across, is going to be a customer need. Okay? As you can imagine, this is made to work on like an Excel spreadsheet or a Google, I don't know what they call it, spreadsheet of some kind. So we're going to have a whole list of customer needs here. So for example, if we're talking about a car seat, it needs to fit with car, and let's just say easy to install. Okay, so customer needs. These are things that you found out on your surveys, you interviewed people, and they're general, right? Fits with car. What does that really mean? I don't know. In terms of engineering requirements, right? Later you're supposed to translate those into engineering requirements. We'll talk about that in a second. So we have engineering needs here, and remember, part of your assignment was to, oh, that was not good. Part of your assignment was to rank these in terms of their importance. So you're gonna put your importance here. And it's not a ranking, it's more of a weight. Importance or the weight, right? For your assignment, you were supposed to give them a weight between however you wanted to do it. Here I'm doing between 1 and 5. You can do between 1 and 10. There can be a lot of 9s. There can be no 9s. It doesn't matter, right? But just a rank between, an importance between 1 and some number. So here we're doing 1 and 5, right? So we're going to say fits with car has an importance of 2, but easy to install, that's fairly important. We're going to give it a 4. Higher is better, right? Higher is better in these cases. Remember that. Higher is better. All right. So now this part of our house of quality, our roof, is going to, well, not our roof, our top floor is going to be our engineering requirements. Okay, so you're going to list your engineering requirements here. And we're actually going to do a couple things. One, we're going to take 2 rows here, and we're going to use these rows to tell the direction / target. Remember how we talked about your engineering requirements should have a direction or a target or a threshold? So, less is better, more is better, or if you have a target, like a target weight, like you want it to weigh 10 pounds, no more, no less, you're going to put that up here on this top row. You're also going to put the units that you measure this engineering requirement in. Very rarely you'll have engineering requirements that don't have units, but for the most part you will, so you'll put your units here. And then we're going to list our engineering functions. So, I wonder if I can erase those. Oh, I can. Beautiful. So, for example, let's say we develop some engineering requirements. Let's first draw our columns here. Like I said, you'll be doing this in a spreadsheet, so you won't have to draw these. But let's say time to install. Was one of our engineering requirements. What was another one? Pleasing to the eye. Which I guess you'd figure out using some kind of survey or some kind of comparison. Actually, just never mind. We won't go into that right now. All right. We also have maybe height. We have weight. And let's say percent of children that can wiggle free, right? So then what we're going to do, once we have these, we're going to try to fill in this area here in the middle. And the way we're going to do it is we're going to do it with a nonlinear measure of the relationship between these our customer needs and our engineering requirements. So we're going to use either 0, 1, 3, or 9. Okay? You see how that's nonlinear? So as we move up, we get 1 extra, 2 extra, focus Craig, 6 extra, right? So it's nonlinear, but we're going to use these different relationships. So let's do this real quick. Fits with car. All right? Fits with car. Percent of children that wiggle free out of our car seat. Does that really matter in terms of how it fits with our car? No. So we're going to put a 0 there. The weight of our car seat. Does that matter with fits with car? No. We're going to put a 0 there. Height. Height. Does that matter how it fits with car? Yes, that does matter. We'll put a 1. Pleasing to the eye. Yeah, that matters a lot with how it fits with the car. So we're going to put 9 there. And time to install. Does that matter at all? No. All right, good. Now, easy to install. All right, this is another customer need. Percent of children that wiggle free. You know, if your kid's constantly wiggling free, it's hard to get them into the seat. I can kind of see how that's related. We'll give it a 1. Barely related, though. Weight. Oh my gosh, if we have a super heavy car seat, it's going to be difficult to install. That's highly related. I'm going to give it a 9. The height, yeah, that's pretty related to how easy it is to install. Not as much as weight. I'm going to give it a 3. See how there's some judgment here in terms of determining the relationship between your customer needs and your engineering requirements, right? You just have to use your judgment and engineering judgment, yeah, and imagination too, right? All right, pleasing to the eye, that's not going to matter at all in terms of how easy it is to install. But time to install and easy to install are obviously very closely related. Okay? So then we're going to come down here, once we've filled out this whole area, put in all of our customer needs, all of our engineering requirements. And you can imagine this thing will get quite large. I worked on one of my research projects with Cummins diesel engine, if you want to look them up. Cummins Inc. And we were working just on oil filters for their diesel engines, right? Just on the oil filtration system. And it was incredible. You should have seen their house of quality that they showed us. It had, and this was, they told us it was a stripped down house of quality, so it was incomplete. But it had over 128 engineering requirements and something like 30 customer needs, right? And they said it was a small house of quality. Oftentimes these can have hundreds of engineering requirements and large number of customer needs, and they can become ridiculous. But obviously when you have hundreds of engineering requirements, you have to have some way of prioritizing them, right? Which is what we're about to do. We're about to figure out which one of these is most important, which one's not. All right. So down here on the basement of our house of quality, get it? It's a house. We're naming all the rooms. We're going to make 3 rows. All right. This is going to be our raw score. And the way we're going to find our raw score is we're going to add each column. First of all, what we're going to do is we're going to multiply the score in each one of these columns by its importance, right? So how do we want to put this? Add each column. But multiply it by importance. Okay, so for example, let's do it with this. We'll just go through and do it for all these rows. So 2 times 0 is 0. 4 times 1 is 4. Add that up, we get a total of 4. 2 times 0 is 0. 4 times 9 is 36. 2 times 1 is 2. 4 times 3 is 12. We have 16. Oh, wait, hold on. Nope. 14. 2 times 9 is 18. 4 times 0 is 9, 18. And 2 times 0, 4 times 9 is 36. Alright. So, now we have our raw scores. We're going to total up, we're going to find our total of all of our raw scores. And that equals, I'm just going to guess because I did not add these up ahead of time. So we have about 72, 86, 104, 108. We'll just say 108. I think that's wrong. I think it's 112, but we'll just say 108. All right, and then what we're going to do is we're going to calculate our relative percent. So that means taking each of these scores and dividing it by the sum of our relative percent is our raw score divided by our total multiplied by 100. Okay? So for example, 4 divided by 108 is roughly 3%. Multiplied by 100 is going to be 3. 36, actually this works out really well, right? Normally it won't work out quite this nicely, but this will be a little bit less than 36, it'll be about 34. And you get the idea, right? What we're trying to do is we're trying to make sure all of our scores fall between 0 and 100, and all of these relative scores are going to add up to 100 in the end. So we're in a sense we're normalizing our scores. And then we're going to determine a rank order. So this is its rank. This row right here is its rank order based on relative score, right? So which one of these is number 1, which one is 2, which is 3. So these tie for 1, for example. This is 2, 3, and 4. Okay? Well, you get the idea. Alright, so now we have a lot of information, right? Now we know which one of these is our most important engineering requirements, which is weight and time to install. Although once we fill out this whole thing, obviously that would change, but for now, so we have a rank. We also know we know which ones are important, which ones are least important. We also know the relative difference in importance, right? So the difference between height and pleasing to the eye is only a few percent, right? 14 versus 18. That's very close. It probably translates into 13 and 16 or something like that, right? 16%. So these two are very close in importance. So we might just weight them essentially the same whenever we're trying to in terms of how much importance they have in our final design. Wonderful. So you're gonna fill this out for your next deliverable and perform this this ranking of your engineering requirements. Okay.